Okay. Now, first one. First one is linear momentum. Linear momentum is just a simple theory. Okay, linear momentum is just a simple theory. If a simple mass travels in v velocity, we say the linear momentum as p, then p equals mv. Then p equals mv. We all know the problem in this section is getting a momentum difference. Okay, the problem is getting a momentum difference. We know we are subtracting, think 5 minus 3. 5 minus 3 is just 2. But if there is momentum, you know this thing, know this thing, but I start this session from A to Z. Okay, I start this session from the beginning step. So therefore, please wait, those who know these simple things. But I am doing this session to A to Z, so please wait for that. The people who know these things. Okay. If we subtract 5 minus 3, think these are momentums. See, the ball is traveling to this with a momentum of, we know the unit is kgms minus 1, and it hit with this ball, and think it comes to this direction, 3 kg ms minus 1. Most of the times they are asking from us, find the momentum change. Find the momentum change. I will explain you later why this momentum change is very important. You know, okay, you know it. Now, we have to always you subtract when you get more momentum change or anything, any change in physics syllabus, any change, you should get it as in this way. Always subtract final thing from initial thing. It is final momentum minus initial momentum. So get these things into your just paper. Don't write these things in books because we are revision students. Don't write these things in a book. But if you are you don't know, nothing to worry. Please write all these things in a paper to get the best result. By this limited time. Don't care about it. This is a simple things. These are not simple. Don't care about that. Right? All things in just a paper. All things. Right? All things in just a paper. Okay. Then momentum change is final momentum minus initial momentum. It means in here the final momentum is 3 kg ms minus 1 to this direction. We should minus it. The initial is 5 kg ms minus 1. So in vector subtraction, we should subtract vectors. By converting these vectors into same direction. Okay, converting same directions. How we convert any vector? By 180 degrees? If you know, you are free to put that in the chat. This is not 28 class. I know this is a revision class, but I want to teach you fundamentals because you are new to me. Okay, you are new to me because therefore I want to teach you fundamentals. So if you like, drop a message or you can help. Okay, reserve the signs. Very good. Okay, then we can opposite the direction by putting a negative sign. Therefore, it is not related to this minus. This minus is okay. Now put some minus value to this and you can change the direction. See, this change to this. Okay, this. Okay, now we can simply simplify that. It means 3 minus minus plus 5. Then they are, what's the angle between these vectors? What is the angle between these vectors? What is the angle between these vectors? 5 and 3. What is the angle between these vectors? Not this, sir. We know this vector is into this side, this vector is into this side. Then angle between two vectors is 108. What is the, we change the direction of this to this, then the direction of these two vectors, the angle between two vectors is now 0. Then we can just simplify, we know that. Okay, this is it. But think, we get the difference between 5 minus 3, but it's become 8. It's not a magic, I know it's not magic for you, you are revision students, but I want to study, I want to teach from fundamental, that's why, yeah. Okay, 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 let's get started. Okay. Now I'm going to tell you what is the importance in this momentum change. We know linear momentum is mass into velocity. We know linear momentum is mass into velocity. Then what is the importance of this momentum change? What is the importance of this momentum change? What is the importance of this momentum change? We know final momentum. Definitely, we should consider directions. Definitely, we should consider directions. And when you are writing essay questions, definitely you write this before all things. Write this equation and just substitute. Final momentum minus initial momentum. Final momentum minus initial momentum. The importance of this momentum change. The importance of this momentum change. It is because of Newton's second law. It is because of Newton's second law. What is Newton's first law? Newton's first law, Newton stated about number 1. Objects which are at rest. Objects which are at rest. Okay. Number 2. Or then we have to work more hours in these sessions. I don't know if you are free or not in these times to get to revise all syllabus. To all syllabus, we have to simply to get a summary, and doing questions is very hard work and more time is needed. Therefore, we have to these lessons for a week. Yeah, yeah. I discuss it with you today. Okay, I plan to discuss it the time per week. I plan to speak with you today because I don't know. I just put this one and I start class. Therefore, we can schedule some. I mean, more than one day, more than one day, we can schedule. Okay, we are at the end of the class, we can discuss it. Okay, it's no worries. We can do more work in this month. Okay. Then in Newton's first law, objects which are at rest. The second thing, objects which are moving in uniform velocity. Objects which are moving in uniform velocity. That is the second category that explaining in Newton's first law. That's the second category. In Newton's first law, he's telling that in Newton's first law, he is telling that the objects which are at rest, the objects which are moving with uniform velocity, never change its motion condition. Okay, never change its motion condition. It means objects which are at rest being rest, objects which are moving in uniform velocity just going in uniform velocity without changing even direction. Direction also not changing. Okay, not only velocity, direction also not changing, not only magnitude, direction also not changed until an external until an external unbalanced force is acting on them. Don't write these things up. Don't write these things. Until the external unbalanced force is acting on you. Don't. In Newton's second law, he describes the object, what happened to the objects if we apply the external force. That is the thing he describes in second law. Okay, in second law, he describes what happened to object if we apply an external unbalanced force. Yet this is t equals 0. This is t equals 0. Assume the initial velocity is v1. It means when I apply the force, the object is running on v1 velocity. Then he explained this. Then the final velocity thing, it is v2 because of this force. Now time is t. During the simple t time, t minus 0. Don't get. I know you all know these things. T means now the t equals 0. In this time t equals t. Don't cut off t equals t. That's the defining of t. T equals t. In this time t equals 0. If we consider such a stage, it can be t equals 1 center. Like that, t equals 1, t equals 2, then this is t equals to t. Okay. Now he's telling the magical thing in Newton's second law. He's told this external unbalanced force. This external unbalanced force is directly proportional to rate of change of moment. Okay, directly proportional to rate of change of momentum. It means F is directly proportional to change of momentum divided by time. That is why the momentum change is important. To find external unbalanced forces, we should find the momentum change in correct way. It means in this way. Sorry. It means in this way. 5 minus 3, this is 8, no? That's the thing. 5 minus 3, because of this opposition of directions, it becomes 8. The difference is become 8. You know, I know you know these things, but I am summarizing. That's the thing. If you want anything right, but I not recommend to write these things definitely. If you want something, please write. I will give some minutes. If you want something, write. Okay. Okay. Any doubts or any questions you can ask? You are free to ask. Any questions? I think no, you know. Okay. Okay. If you have any questions, you are free to ask them. Just ask. There is no issue. Okay. 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 And this is the momentum change case. We know the Newton's third law is every action has a reaction. These things. Can you remember this for just simple test? See this. This. This is the last month, but don't panic. This is the last month, but don't panic. Do your things, do your works in, do those things in a speed, but you should do it accurately also. Okay. So I will give you a simple question to check you. Okay, I won't check you. Therefore, I will give a simple question. It is very simple. Uh, Definitely do this. Don't think this is simple for 26 people. Okay, don't think it's simple for 26 people. Just do it and give me the answer. 2 kilograms. And this is 30 degrees. This is 30 degrees. Okay. Coming with 3ms minus 1 and collide with this hand. It comes off to this direction by 3ms minus 1. We know this is the initial condition, this is the initial condition, and this is the final state. Mass is 2 kilogram. So find the momentum change. Please put the answers if you are just a simple. Find this. That's the momentum change. Don't be too speed. Don't be too speed. Okay. We doing all of the things during this month and understand better. Understand the concept better. Understand the concept better. Okay. Until the concept is understanding, don't be very speed. Just try. Just try. Just understand more accurately these concepts. That's the most best thing. Okay. Okay. Find the momentum change. Put answers up. Put your answers. Now we are like friends. Okay. Now we are like friends. We can share anything about this education or the subject. Anything about subject you can share with me. And you can get help from me to solve it, just context questions or anything. Okay? Don't panic and do. If you have any doubts, if you have any questions, please ask from me. Okay. Okay. Thank you. Thank you for your answer. Okay. we'll check. We'll check. Thank you for that. Anyone? If you get the answer, please, you can put it in WhatsApp also. Anywhere. Please send me your answer. No others, no? I think you are a little bit better. Huh? Therefore, I told you to don't give these things in simple. Huh? So I think you are very full ready people to exam. So these are very simple problems to you. Okay. I assume my assumption is that. So I need some more answers for this. But if you are not, if you are unable to do this, no issue. We try that. We try it during this month. Yes, yes, we can. Okay. Only one. Still only one. Right? I asked 6 kg ms minus 1, right? Okay, we'll see. Okay, we'll see. Please give your attention, please. This is the initial condition, no? This is the initial condition. So we should resolve these vectors. We should resolve these vectors. We know 2 multiplied by 3, 6 kg ms minus 1 is to this direction. The momentum changes happen. The momentum changes happen to this direction. Please get it into your mind. It changed to this. It hoped to go this direction. But because of this collision, it changed by this angle. You know the angle of dispersion, deviation in light, like that. It deviates. This is the initial direction. The final direction is this. It deviates its path. So, this is 6 kg ms minus 1 and this is 30 degrees. Now, we should resolve this. We can resolve this. See, we can resolve this. This 6 kg ms minus 1 to this and to this. It means to this direction, see, to this direction, 6 sine 30. 6 sine 30. Then to this direction, see the direction, huh? To this direction, 6 cos 30. Six sine 30, 6 cos 30. Then we can resolve this also. We can resolve this also. 6 cos 30. 6 cos 30. We can resolve this also. 6 cos 30. It is to this direction. Then we should resolve this 6 cos 30, 6 sin 30. 6 sin 32 downwards. We can clearly see to the downward direction, the momentum does not change. Momentum does not change. But this direction, momentum is changed by 180 degrees. Momentum is changed by 180 degrees. Therefore, normally we are checking the momentum change to both perpendicular directions. Always we should take the momentum change by final momentum minus initial momentum. So this direction, final momentum is this. 6 sine 30 minus initial momentum is this 6 sine 30 equal directions and equal magnitudes 0. The final direction is this one. Please get that. The final direction is this. So 6 cos 30 minus the initial direction is this. It is also 6 cos 30. Therefore, we have to simplify this. 6 cos 30 minus 6 cos 30. It is to this direction. Yes, then this become plus. Plus, it means 2 into 6 cos 30. 2 into 6 into cos 30 means root 3 over 2. Then the answer is 6 root 3 kgms minus 1. To what direction? This direction. See, the ball is traveling from this to this. Ball is traveling from this to this. But the momentum changes to the direction of the left. Left means west direction. Okay. The momentum changes to this direction. Okay. Then 6 root 3 means I think some solve with I think some guy tell this answer 10.39. I saw this answer kgms minus 1 10.39 na? 10.39 who sent 10.39? 10.39 means 10.4 10.4 okay 10.4 okay. Get this. If you need this simplification, get this. If there is any questions, you are free to ask. I don't tell it again and again. If you have any questions, you are free to ask. Okay, I will give some time to the people who are writing this. The momentum change is over, it slows over. Now we are going to discuss some more questions from this. Okay, sure. Thank you. Thank you. Okay. Okay. If you are getting this, give me update. Okay. Now, in Newton laws, in Newton laws, there are two types of questions. Only two types of questions in Newton laws. The one type is using F equals ma. F equals ma is these thing, these type questions. These things are set up by this type model, and we are applying capital F mass to both system of masses. And this is M1, this is M2. This is a string. We know in a string, always tensions are to the inward directions. Always tensions are to the inward directions. We know that in a string, always tensions are to inward direction. So we can freely mark tensions to this direction because this is a same string, the single string. The tensions in all places of the strings are equal. The tension of the all places in the string are equal because it's the same string. Like problems. We should apply F equals ma. Okay, we should apply F equals ma. I need some space. F equals ma to what? To single masses, to single objects, otherwise systems of objects. We can apply F equals ma. Okay, we can apply F equals ma to single objects and systems of objects. We can apply F equals ma to this single object M1, this single object M2. Also, we can apply F equals ma to the both M1 and M2 system of the objects. Both in the total system. We can apply F equals ma to total system. Okay, to the total system. Then this is a string. We know that. The other main thing is, these pulleys. These pulley related questions. Don't panic with these things. I'm doing separate questions straight to this, but I summarize it. I summarize this. And the other type is the questions that can be came from Newton laws. The other type is we know not only F equals ma, F equals to the momentum change over time. That means F equals delta mv over t. From this equation also they are asking problems. They are asking problems like things like that are moving in some velocity and they are accelerated and they increase their momentum during this time. Okay, we are doing such questions also in here, but get these things, into your paper. Okay, hurry up. Any messages from you? Okay. Okay, yeah, 10.4. I saw now. 65 plus. Oh, sure you can. Aisha, I think Aisha, sure you can. For it's easy the average mark for the final mark. Is it 65 plus 6 average mark to all papers? In all papers, is it your average mark for is it the 65 plus for the final mark? Both you can both, if any, you can do good thing in physics paper. Is it for your test or some paper in your paper class that you are attending this update. So fee, the answers be left with fruits is turning to decimal. Yeah. You should turn it decimals. You should turn it and decimals. It means you should simplify. You should simplify your answers to 3 decimal places. You should simplify your final answers to 3 decimal places and round off to 2 decimals. Round off to 2 decimals. Okay, that's the standard method that we are keeping answer professional method. Okay, so sequence formation. Yeah, okay. Is it okay? Very good. Very good. 65 marks, 65 plus mark is very good mark. Okay, 6. Okay, I'm very happy. Okay, police and these things. Okay. No. Again, these are the two methods. We can draw FT graphs. Okay, we can draw FT graphs, and there is an equation for impulse. Okay, we know impulse. Always impulse equals to force into time, and according to the Newton's second law's definition, we know F is equals to final momentum minus initial momentum over time. This is a separate definition. Impulse is force into time. Force into time means this force should be what? What is this force? When we are getting impulse equals force in time, what is this force? Always this force should be resultant force. Always this force should be resultant force. You can see the importance of this by doing the question. Next, we have a smart question. We have to do a smart question after this theory. So this way, you can see the importance of this, the resultant force. You should get this F as resultant force. Then F into T, we know we can just multiply this T with F. Then Ft equals mv minus mu. Then Ft equals mv minus mu. What is Ft? Ft is impulse. Impulse equals momentum change. Please get these things to your paper. Get these things to your paper. Oh, please. And this Ft is impulse, impulse is momentum change, then think about graph, Ft graph. What is the thing that coming from this area? What's the thing that comes coming from this area? Momentum change. By the area of a Ft graph, by the area of a Ft graph, we can get the momentum change. Okay, we can get the momentum change. Okay, clear? Clear these things? Okay. Get these things into your paper, and if any doubts, ask for me. Okay, clear. Any questions? Please drop a message. No, no questions. No messages, no questions. Okay. Okay. Yeah. Resultant force for impulse. Resultant force means think if there is a force to this and always there is mg F1. If we think about that, we want to get some impulse to this equation, we should get F1 minus mg, the resultant force. F1 minus mg, the resultant force. We should get the resultant force. That's the thing. Okay, that's the thing. Okay. Now the problem, we know that now Ft, momentum change, the area of Ft is also momentum change, we know that. Now the problem. I will give you a Ft graph. The Ft graph is this. Okay, the Ft graph is this. This is 450 Newton. This is 450 Newton, and this is 1430 Newton. This is 450 Newton, 1430 Newton. This time is 0.3. This is 0.4. Don't care about this scale. There's no scale here. 0.4. Now, this F is the force that acting on feet of a man body ground. He is trying to jump. is trying to jump. When we are trying to jump, always we push the ground and get some force from the ground on us, on our feet. Okay? That is the way we jump up. That is the way we jump. That means there's a man here. This is the ground. When we want to jump, we should give a force to ground and we get the force to upward. That is how we jump. Okay, I don't explain furthermore because of the question. Okay, first do something on this question. The question is this. This is the F, and during this 0.4 time, during this 0.4 time, man get away from the ground. Man get away from the ground. The question is, find the velocity which man get off from the ground. The velocity which man get off from the ground. Okay. In this time, this is not a second. These are 0.4 seconds. So in this time, he pushing the ground and getting the force, and finally he get off from the ground. He get off from the ground at this point. Okay. He get off from the ground when t equals 0.4. Find that velocity. That's the question. If any unclear things, it is 1430. Okay. Yeah, 1430. Use some try. Alright. Anyone who get answers? Don't need mass. Oh, uh, you should get it. So this is not 400, huh? This is 650. This is 650, okay? Mass is already gave in the question. Find it. Mass is already in this question. The mass of the man. You should get that. Then okay. Any questions? So don't be, yeah, you need the mass, but you should get that from the question. Please send your answers, huh? Send your answers for me. This is 650. This is not 450, this is 650. I'm very sorry for this. Okay. Any answers? Hmm. Okay. Now, see, when t equals 0, when t equals 0, the force from the ground on the feet means perpendicular reaction. Okay, this is the perpendicular reaction. This F is perpendicular reaction. And we know mg is there. At t equals 0, that is 650. It means at T equals 0, 650 equals to mg. Then we know the mass of the man is 65 kilogram. Then we know the mass of the man is 65 kilogram. The mass of the man is 65 kilogram. Then during this time, he increases the force on the feet from the ground. Okay, he increases the force on the feet from the ground. Then it means we can just apply and get this area. But from this area, we can't get the momentum change. Okay, we can't get the momentum change from this area because this force is now perpendicular reaction. It is not the resultant force. Always the resultant force is derived from deducing the mg from this value. Think at T equals 0, what is the resultant force? At T equals 0, what is the resultant force of this person? At T equals 0, what is the resultant force? 0. We should draw the graph again. We should draw the graph again for this. We should draw the graph again. It is not hard. Subtract the graph from 650. Then new graph is this. What's the value of here? This is becomes to 0. Then this becomes to 1430, 650, 0, 13 minus 5, 8, 13 minus 5, 8, 13 minus 6, 7. And this is 7. If you get the area of this, you can easily get MA minus LT. Then this is 0.3 and this is 0.4. Then this is the area of the trapezium, 0.4 plus this is 0.4. 0.4 plus 0.4 minus 0.3, this is 0.1. So 0.1 divided by 2 multiply by perpendicular height 780. This is the momentum change. The initial condition, at the initial condition he is at rest, and the final condition is the moment that he get out from the ground. Then 65 into V minus 65 into 0. 65 is the mass of the man. Then this is 0.5. This is 0.4 plus 0.1 is 0.5. Over 2 into 780 equals 65 into V. Then 2 and we can cut off now. What is the answer? 780 divided by 2. 390. 0.5 is half now. 390 over 2 equals 65 into V. Then we can get V 390 by 2 divided by 65. It is 3. V is 3 ms minus 1. That's the answer. Okay, get that. Okay, any questions? Hmm. Okay. So always in this equation, and if we get area also, F should be the resultant force. Okay, F should be the resultant force. Okay. Where did zero come when considering trapezium area? Zero. What zero? This is trapezium area. This is not. This is momentum change. Huh? This is momentum change. When we get in momentum change, okay, when we get momentum change, the initial condition is zero. That's right. The initial condition is zero. Okay. Right. Okay. Then that is the impulse. If T equals mv minus L. And this question is related to the second part. Okay. The second part means I told you. The one thing is F equals delta mv over T. The other part is F equals mv. Okay. That problem is related to F equals delta mv over T. Okay. This part. Okay. Now. Okay. Now we are Newton laws. Okay. F T impulse. Okay. Now the energy. If we are summarizing about energy, there are three types of energy in our syllabus. The first thing is potential energy. Potential energy. In potential energy, there are two types. gravitational potential energy. The other thing is elastic potential energy. The second one is kinetic energy. Okay. The second one is kinetic energy. We know the equation of the kinetic energy is just K equals half mv squared. And the special thing is, we know now PE and KE. What is the single word that we are telling? PE plus KE. What is the single word that we are telling? PE plus KE. PE plus KE. Anyone? Not total energy. We say to that mechanical energy. Okay, we say to that mechanical energy. Mechanical energy. When we are finding gravitational potential energy, the simple equation is mgh. The simple equation is mgh. Elastic potential energy also there are equations. Okay, half k squared, but I want to explain this deeply. Get this into a paper. Before that, get this all things into your paper. Hurry up. Okay. Quickly get these things into a paper. Okay. The kinetic energy is just half mv square. Potential energy is just mgh. The energy, potential energy plus kinetic energy is mechanical energy. Potential energy plus kinetic energy is we say mechanical energy. Okay. Now, elastic potential energy. Okay. Elastic potential energy. Now there is a spring. Suppose there is a spring. Now the spring is in unstretched condition, unnatural, otherwise unstretched. Now I'm stretching it to some distance. The initial length is capital L. The initial length is capital L. In here also this is capital L. And this is we say elongation. Okay. And this is we say elongation. Elongation. No. To stretch this, we have to apply a force. we have to apply force. But in Hooke's law, it is telling that this F is proportional to E. F is proportional to E means F is increasing with E. Okay, F is increasing with E. What is the value of F when E equals 0? What is the value of F when E equals 0? E equals 0 means this condition, no? When E equals 0, what is the value of F? What's the value of F? 0. Very good. When E is increasing gradually, F also increasing from 0 to greater values. Then F is not F is not constant. Think if this is 5 Newton, if this is 5 Newton, when we stretching this, the force is increasing 0, 1, 2, 3, 4, 5, like that. Force is not constant. Force is not constant during we doing work. Force is not constant during we doing this work. Okay, we know the work. There is a mass. We are applying force. Because of that force, the gravitational center is traveling. Okay, the gravitational center is traveling. Suppose s distance. The gravitational center of the object traveling s distance because of this constant force. The force is not changing. Then we know the work can be calculated by F multiplied by S. Okay, we can calculate the work by F multiplied by S. Then, if this force is changing, okay, if this force is changing, suppose this F1, because of this F1, this object is traveled to this point, and this is S. See always the gravitational center, the motion of gravitational center. Okay, the motion of gravitational center, the distance, the displacement to the direction of the force. Now here force is changing. This is F1, this is F2. In such places, we are getting force by average force. We are getting work by average force. This is average force. Average force should be multiplied by the displacement to the direction of the force. Okay, average force should be multiplied by the displacement to the direction of that force. That's how we getting work done. Did you get this? This and this? Did you get the difference between these things and how the equation is changed? Any questions? If any questions, please tell me. No any questions? Hello? Okay, got it. Then in here, okay, get these things into a paper. I want to erase this. I want to erase these things, so get this into a paper. Okay. Okay. Okay, Kavish. Got it. Okay. Okay. This is Fs. This is mean force multiplied by distance. Now in here, we are doing some work. We are doing some work on this spring. Then work done on the spring. The work done means stretching this. Work done means stretching this. Then work done on the spring is the energy, the elastic potential energy stored in spring. Stored in spring. The elastic potential energy stored in spring. Now, this is the PE now. PE elastic. This is the PE elastic. The work done on the spring is now, we should get the average force in here also. When E equals 0, F equals 0, when E equals E, F equals F, just that. Then the mean force, what's the mean force? Mean force is the initial force plus final force divided by 2 into E means the length that is stretched, the length of this spring that is stretched. Then we can get the equation F half F E is PE elastic. By Hooke's law, we know F is proportional to E, then F equals K. K is the spring constant. Write all these things, huh? Write all these things. K is the spring constant. K is the spring constant. Then we can apply K into this place. KE instead of this F. Then KE, this E is here. Then it is become PE elastic. There are two equations for PE elastic. Two equations for PE elastic. One is half KE square. The other one is half FE. Okay, K is spring constant. Any doubts? Ask from me. If there is no any doubts, get these things into a paper. Definitely write these things. Definitely write these things. Huh? Okay. Okay. If any questions, please ask from me. Okay. 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 Anyone writing? Anyone writing this? Please tell anyone writing. Please. Okay. Okay. All okay now. That's the spring case. Okay. There is a spring here. Now, 2 kilogram object is traveling from 4 ms minus 1 velocity. And this is smooth. This is smooth surface. This is smooth surface. And this becomes an hit with this. This becomes an hit with this. The question is, find the maximum. These are basic questions. Huh? Okay, I said to you. This is this is the this is the very first day of us. Therefore, I give you basic questions today. So please wait. There are some sessions that we are discussing complex questions. Okay, but I need to see who are you, at what stage you are in. Therefore, please do these things. Find the maximum elongation. Find the maximum elongation of this spring. Okay, try this thing. Try and give me answers. Okay. Okay, try this question and give me answers. Oh, sorry. Oh my God. That's compression now. Thank you. It's not elongation, it's compressed. Compression. Thank you. If you get any answers, please send me. Yeah? Constant. Please wait. Spin constant, no? Take spin constant as 4. Take spin constant of this spin is 4. We needed the spin constant one. It is 4 nm minus 1. The unit is nm minus 1 no? Because it is f equals kx. K equals f over x. So unit is Newton per meters. So newtons per meters. The unit is that 4 nm minus 1. Then we are going to solve this. Here, the energy conversion is this. Energy conversion is this. Kinetic energy of the ball, kinetic energy of the ball equals to the energy stored in equals to the energy stored in the spring. The energy stored in the spring. The kinetic energy of the ball is half 2 4 squared equals. Now this is after hitting this spring, kinetic energy is decreasing and that kinetic energy converting to the elastic potential energy of this. Okay, please wait. I will check. I will see you answer 6.36 meters. We'll see. Yeah? 8 is the answer. We'll see. Okay, thank you. Thank you for your response. Okay, the energy stored in the spring. Now the energy stored in the spring is we know half k square. I think you can remember half k is now 4, then e squared. Now what happened? This 2 and this 2 cancel out. 4 into 4 16, 4 into 4 16, and this 2, 2 squared, 2 squared, then 6, this is 1, this is 8, 8 equals e squared. Then 8 equals e squared means e squared equals 8, then e is root 2 meters. It is 2 root 2 meters. Okay. This is something that 2 root 2 meters. Okay. Please write that. 2 root 2 meters. Okay, 2 root 2 meters. Please get that. Okay. After this question, we are summarizing the frictional forces. After this question, we are summarizing the frictional forces. So, as a final question of energy, please do this. Now, this is another ball. This is 2 kilogram. This is 1 kilogram. Now this ball is comes and hit with this ball. Okay, hit with this ball. Yeah. The angle is 30 degrees. This is 6 meter in length. Okay. This is the A ball. This is B ball. The collision is, okay, there's a collision with this A and B. The collision between A and B is, the collision between A and B is a fully inelastic collision. Do you know what type of collisions there are? Full elastic collisions, and elastic collisions. No difference. No difference between full elastic collisions and elastic collisions. And there are some it's inelastic collisions. And there are things totally otherwise fully inelastic collisions. Fully inelastic collisions, inelastic collisions, fully elastic collisions. Okay. Before the question, I will explain you. Then we know conservation of linear momentum, conservation of energy conservation. Energy conservation. This is not mechanical energy conservation. This is not mechanical energy conservation. This is energy conservation, and there is separately mechanical energy conservation. If we consider energy conservation, energy conservation is always valid to all of these conditions. Valid. Energy conservation does not break down any other collision, inelastic or full elastic or anything. Inelastic means not energies. The inelastic means not energies wasting. Inelastic means not energies wasting. Kinetic energy wasting. But kinetic energy also not wasting. It is converted to some other energy type. Okay. Inelastic or fully elastic or fully inelastic or all forces. Energy conservation is valid. But in full elastic collisions, kinetic energy conservation also okay. Kinetic energy conservation. That means kinetic energy existing same. It does not change. After the collision, before the collision, kinetic energy is equal. But here kinetic energy conservation is not valid. kinetic energy conservation is not valid. Linear momentum valid for conservation of linear momentum valid for. But keep it in your mind, energy conservation does not break down. Energy conservation do not break down. Okay, energy conservation do not break down. In fully elastic, kinetic energy conservation also valid. That's the thing. But the special thing is if the collision is fully inelastic, if the collision is fully inelastic, two objects are get attached. Okay, if the collision is fully inelastic, definitely two objects will attach. ඇලෙනවා වගේ එකක් වෙනවා. objects දෙකම ඇලෙනවා. ඒ කියන්නේ mass same කියලා consider කරන්න පුළුවන්. ඉස්සර මේක දාගන්න. ගානට කලින්. Okay, put these things in your paper. After that, try the problem. If any questions, ask from me. If any questions, ask. About mechanical energy conservation for non-elastic. Mechanical energy conservation is not valid. Yeah, inelastic. It is because it in sometimes it can be kinetic energy. Mechanical energy means kinetic energy and potential energy. No? Then in some occasions, kinetic energy can be converted to sound energy or something. Heat energy. So they are not related to the mechanical energy. So mechanical, not mechanical energy conservation, only energy conservation. The mechanical energy conservations are all are valid for full elastic. No difference between full elastic or elastic collisions. Both are same. But there is a difference between inelastic and full inelastic. Okay. The main difference is in full inelastic collisions, objects are being attached. That's the thing. Okay. Okay. If you get any answer, update me. Okay. Hmm. Questions you have. Start. Okay. Yeah. Sure. Okay, I will guess this. Huh? Then this is a fully inelastic thing. The fully inelastic collision means this capital A ball attacks when they get collides. It means before the collision, A is coming with some velocity. After the collision, A and B get attached. After the collision, A and B get attached. Then we can treat both A and B as uh, single object. This is V1, take this is V1. First, we should find this V. Okay. Finding V is this is 2 kilogram. Capital A is 1 kilogram. Capital A is 1 kilogram. Capital B is 2 kilogram. Then what is the velocity here? Is 2 kilogram. We should find the velocity of this. This is the V now. Okay. With this V, capital A is getting with capital B, which is at rest. B is at rest. Capital A is coming and hitting with that. Then it becomes single. We can get both of these are single object because it is fully inelastic object. That's the reason. Okay. Now we can find V by using energy conservation. Now these are the levels. These are the two levels. When we are using energy conservation, okay, when we are using energy conservation, we should take a zero potential level. Always my recommendation is to take the zero potential level as much as you can the bottom line. As much as you can with the as much as the bottom line. Then this is the line PE equals 0. This is the line PE equals 0. We are applying mechanical energy conservation. That means this is the before, this is after condition. PE1, the one is the before condition. Nah? This is one condition. This is the second condition. PE1 plus KE1 equals PE2 means potential energy here. KE2 means kinetic energy here. Now, after we selecting the zero potential line, there is a sign convention. Okay, there is a sign convention. That is, if we are measuring upwards, if we are measuring heights to upwards from our zero potential line, they are positive. If we are measuring downwards heights, if we are measuring heights to downwards, they are negative. They should be measured negative. Then we should find this height, no? We should find this height. This is zero potential level. We should write the potential energy of this in this place. So we have to find this height. Please see that this is a right angle triangle. Then we can easily find this height. And always we know, because this is 6 meters, the height of this is 6. This is 6. Therefore, this is coming to here. Then the complete line is 6. This can be found by simple trigonometry. This distance can be found by simple trigonometry. The simple method is, if we know the hypotenuse, you can just get 6 cos 30. If it is hypotenuse, you can just get 6 cos 30. 6 cos 30. You can just get 6 cos 30. Otherwise, you can get cos 30 equals, this is the adjacent side now. Cos 30 equals, adjacent side is just get h. H equals hypotenuse, then 6 cos 30. Then the h1, the distance that we need is, can we get 6 minus h means 6 cos 30. Please get as 60. Yeah? If it is 30, it becomes the simplification is very complex. So get this 60. Then 6 minus cos 60 is half. 6 minus 3, there is 3 meters. H equals 3 meters. Not H. H1 equals 3 meters. Then we can first find V. How we first find V? The PE1 is now m, g, h is 3. Kinetic energy is 0 in this place. because they are saying the object starts this motion from rest. U equals 0. It is equals to the potential energy of this place. This is the zero potential line. We measured heights from this place, so potential energy is 0 in this place. Now this is the place that gives us answer. That is half mv square. This v is this v. Now, okay, I want to simplify this thing. Okay, this is mg3 and this is half mv square. So m cancelled. Now g is 10. 3 into 2 is 6. Then v squared equals 60. V squared equals 60 means v equals root 60. Don't worry. Don't simplify this. They're not asking this one, so keep this in here. Now simplify කරන්න එපා මීට වැඩි. මේක නෙමෙයි නේද? ඒක සම්මුතිය. Now we should apply conservation of linear momentum for this. Conservation of linear momentum. When we apply conservation of linear momentum, we should prefer a direction. I prefer this direction. Conservation of linear momentum means total, I get linear momentum as Lm. Total Lm before the collision equals, we should get the same direction in here also. Total linear momentum after the collision. Okay. Back in the back. It's 1 kilogram and 2 it is 3. Yeah. Yeah, you're right. When we apply the equations, we can put that. Because at it's 1. No. You are asking about this cutoff by M and N? I think you are asking about that. This is applied to this one. I just find the velocity of this. These are same. No B is in here. Now this is comes from this and take a velocity. With that velocity, it hitting with this B. For the collision, this equation. But before the collision, this is before the collision. We should find the velocity of capital A. This is capital A and this is also capital A. Get it? This should be, then there is a velocity. With that velocity it climbs. Yeah, okay. Before this, we find that velocity. After that, this capital A going with this. But there is assume this string is cutting in that momentum. Otherwise, the string is stretching because they both are going to assume that cutting this string is cut. Now, total linear momentum before the collision is capital A. The mass of capital A is 1. V is root 60. Plus, now before the collision, B is 0. That's the thing. B is 0. Now we can consider both of these masses as a single mass because this is fully inelastic collision. Now we can put 1 plus 2, and this is the velocity that they are asking. Now root 60 equals 3 into v1. We can write root 60 as 15 into 4. Yeah, 15 into 4. It's okay. But if this answer is like this form, there's no issue. That's the final answer. If you have any other questions about this, please ask me. Otherwise, write down. After this question, I'm going to discuss with you about friction. Okay, I will give you nearly 3-4 minutes, 5 minutes, 5 minutes to complete this. Okay. Now write the friction as topic. Friction. Friction. First, we have to identify and understand how we mark frictional forces. How we mark frictional forces. Then, think there is an object. There is an object. If there is an object in this place, there is an object in this surface. Normally, the object is in a surface like this one. But when we drawing free body diagrams, when we drawing FBD, free body diagrams, we have to draw keeping some gap to draw free body diagram. Okay, we should keep a gap in contacting surfaces. So I'm keeping this gap. Now, suppose the mass of this is capital M, then weight is capital Mg. There is a perpendicular reaction in here, and there is a perpendicular reaction in here also. This is the normal free body diagram for an object which is kept in a surface. Normal free body diagram of an object which is kept at the surface at rest. Which is kept at the surface at rest. Now, if we apply a force on this object, if this is not smooth, this is a rough space. This is a rough space. If I apply a force, now this contacting surface, to what direction applying the force on the surface? This contacting surface contacting with this surface, no? So because of this force, this surface applying the force on this surface to this direction. This is the force applied on surface, by the box. According to the Newton's third law, there is a reaction. We know action and reaction are acting in separate objects. Okay? Action and reaction never acting on the same object. Always they are acting on separate objects. Therefore, this is the action, this is the reaction. And this reaction is the frictional force. This is the frictional force. We know this means. This is the frictional force. For such occasion, we know how we mark the frictional force. Now, think about a wheel that rotating. Okay, think about a wheel. Okay. If there is a wheel, that rotating, there is a wheel that rotating. Now the wheel is rotating. This is the point which contact with the surface. Now please think, this point will apply the force to this direction on the floor, on the ground, the wheel is rotating to this direction, then this point will apply the force on the ground to this direction. Then the reaction is to this direction. So always frictional force is not acting to the opposite directions. Always frictional force is not acting to the opposite directions. In here, okay, frictional force is acting to the opposite direction. But in a wheel, see, a wheel, see, this point is applying force on the ground to this direction. Then ground applies the force on this direction. You get this? So is it okay? That is how we get it frictional force, the direction of the frictional force. The first thing is identifying the direction of the frictional force in any occasion. Is it okay? Is it okay to you? No. Any questions? Others? No. Okay, draw these things. Draw these things. Hurry up. This is one. This is second image. You should draw MG also. MG and this is third one. And I draw the fourth one here. All contacting surfaces are rough in here. All contacting surfaces are rough. Here and here. This also rough surface. I applied force this object. Then we should mark the frictional forces in this diagram also. Is this thing so? There. Okay. When I put this with this force, this surface applying force in this direction. Okay. This surface applying force in this direction. And then this surface applied this. Now, this is the critical case. When I apply a force in here, okay, when I apply a force in here, when I apply a force in here, this surface will apply a force in this direction. This is F1, this is also F1, this is also F2, and this surface will act a force to this direction. And there are tensions saved. Okay. Okay. Throw these things. If any questions, please ask. Otherwise, throw these things. Now, after this, there are three types of friction. First is static friction. Second one is limiting frictional force. Third one is dynamic frictional force. Okay, third one is dynamic frictional force. Okay, did you get this? Any questions you have? No questions, no? Okay, you have no questions. Okay. There are two frictional coefficients also. Mu static. The other one is mu dynamic. Then by these things, we can get two types of frictional forces, the magnitudes of frictional forces. Then the special thing is the limiting frictional force can be get from, okay, the limiting frictional force can be get from static frictional coefficients into R. Static frictional coefficient into R is the perpendicular reaction. The dynamic frictional force can be get from F dynamic equals mu dynamic into R. Then all of these frictional modes are depends on, okay, all of these frictional modes, these are frictional modes. All of these frictional modes are depends on, all of these frictional modes are depends on the magnitudes of the applied force, okay, depends on the magnitude of the applied force. This is applied force. Okay. If applied force is less than, okay, these are the three types of frictional forces. Now I am telling you how we get these frictional modes. Okay, in what conditions these frictional forces are acting on the object. First one is if the F applied is less than F limiting frictional force. We can find the F limiting by these equations. Then always frictional is static friction. The specialty of static friction is, okay, the specialty of static friction is, the specialty of static friction is that frictional force is equal to the applied force. Therefore, object will not move. If we are applying force, we are applying force, but if the applied force is less than limiting frictional force, but if the applied force is less than limiting frictional force, then the frictional force is also the applied force. Therefore, its total becomes zero. Object will not move. Object will not move. Then the other thing. If applied friction force is equals to F limiting friction force, then frictional force is this. Now, F equals F limiting. This means near to move. Near to move. After little time, object will move. And this is the maximum frictional force that can act on the object by the surface. Okay, this is the maximum frictional force. No any frictional force above this. Third one, if applied force is greater than this F limiting force, definitely object will move. Definitely object will move. Here, frictional force becomes F dynamic. Okay, frictional force becomes F dynamic, and if the dynamic frictional force is somewhat less than the limited frictional force, and this is constant. Even we increasing the applied force when it becomes dynamic mode, when the object system becomes to dynamic mode, when it starts the motion, if we increase our applied force, if we increase our force, but dynamic friction doesn't change. Dynamic friction doesn't change. It's constant. That's the thing. Okay. If any questions, please ask me. Otherwise, get this in your paper. Okay. 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 No questions, no? Right. Okay, now the exercise. They are giving this as static. They are giving this as static, but it gives the limiting frictional force. This is not static, but they are giving is as static. This 0.5 new limiting equals 0.3. New limiting equals 0.3. There is object here. The mass is 2 kilogram. It means 20 Newton. So here the frictional force F R 20 Newton. New dynamic. Oh, yeah. Sorry. New dynamic. And this is applied force. And this is frictional force. Resulting force also. 0, 1, uh, 2, 4, 7, 8, 10, 11, 15, 25, 100. Can you feel this? Feel this by using above data? I will give some time. Okay. First of all, we should find. First of all, we should find F limiting frictional force. How we find that? F limiting equals mu static into R. We know R is now 20. 0.5 is half 20. 20 to half means 10 Newton. 20 to half is 10 Newton. Okay. Now find F dynamic also. If they are giving mu dynamic, find F dynamic definitely. Then dynamic is 0.3 into R is 20. 3 over 10 into 20, then this is 6 Newton. Now, this is the area applied force is less than, okay, applied force is less than limited friction force, because limiting friction force is 10, no? Limiting friction force is 10. In this area, friction force is applied force. And if we apply what? 0, 0. If we apply 1 Newton, friction force is 1. If we apply 2 Newton, friction force is 2. If we apply 4 Newton, friction force is 4. If we apply 7 Newton, friction force is 7. If we apply 8 Newton, friction force is 8. If we apply 10 Newton, friction force also 10. It also 10. But if we apply 11 Newton, take this is as 10.1. If we apply 10.1 Newton, applied force now greater than the F limiting. Applied force now greater than the F limiting. Okay, applied force now greater than the F limiting. Then what happens? Then what happens? The frictional force change its mode to dynamic. Dynamic is 6. It does not change. Now what is the resultant here? Resultant for 0, 0, 0, 0, 0, 0, 0. Not moving. But in here, 10.1 minus 6, it is 4.1, 9, 11. No, not 11. So it is 9. That's how they are moving with this resultant force. Okay, no? Okay, clear? Frictional force is okay. Hello? Clear. Okay. No any questions, no? Okay. Get these things. Okay. Okay, we have we want to do some light part also. I'm thinking about that today. Do we put light or not? Okay, we'll see. Yeah. If you have any shape any something in the time, please update me. Okay. If you have any quiz or something, some students have quizzes also in night time. If you have any work, please update me. Okay, then we can do it. Okay, it is friction bar. That will be these things. Okay, friction also done. Friction also okay. Now, friction also okay. No. Get your past papers. Now get your past papers. Get to 2015 annual paper. Get 2015 annual paper. Maybe 28 question is another. 28 MCQ. 28 MCQ to try something now. 2015 का 28 MCQ का. Hmm. Right. Ah, right. Yes, 1,500 years. $50 person, 6 ms minus 1. This becomes to 0, its velocity becomes 0 during how much time? 0 to 0.2 seconds. Then we know F equals delta V over T. F equals delta V over T. They are asking about F. They are asking about F. Now delta V is 50 into 0 minus 50 into 6. Always final minus initial. Final is 0. Time is 0.2. Then here this is 0 minus 50 into 6 over 0.2. Now get only magnitude, 50 into 6, 0 point is 2 over 10, 2 over 10, then should come to this plus 30, 1,500 divided by 50 into 3, 150 into 10, 1,500 Newton. However, they gave all for this MCQ in 2015. Okay, in 2015 they gave all as in marking scheme. It is because they are telling that this is not a single object. This is a man, the body of a human. Therefore, there is some doubts in that question. How all parts of the bodies comes to zero, only one part in this time in a constant time in the same time, how all body parts are becomes to zero? There's a question. So they give all for this other part because the in physics theoretically we can solve this question in this way. Okay, please get that done. Okay. Okay, decided. Now energy also okay now. We did the revise. This is only a revision. This is not a theory class. This is a 1 month revision program. No? This is 1 month revision program. Okay. Now we should discuss in mechanics. Okay. Before the question discussion, before the question discussion means before the exam, before August, we are doing special MCQ discussion. Some special MCQ discussion and SAI structure this is also before August. This is just a start up, okay? Today we just start and I explain you normal mechanics theories, and we have to uh, do this circular motion, rotational motion, okay, circular motion, rotational motion, fluid statics, and Bernoulli. Okay. Now we are continuing here. Continue from here. Circular motion, rotational motion, fluid statics, Bernoulli. So we discuss in light in another day. Okay. We discuss in light lesson in another day because we have to continue and complete this. Therefore, I'm doing these lessons for now. And in this special MCQ discussion, we are discussing some complex problems that are in exam level, and some questions are about exam level. Okay, we can discuss some MCQ discussions also before August. Before August, okay, in July. Then during this month, we should revise the syllabus with these live sessions and some pre-recorded videos. Then we can do our class every Monday. Okay, in every Monday this time we can continue our class during this month. I need to get another day week per week. If we can get another day to discuss these things, it will faster our process. Okay. We'll see what's the day. It's a problem in time also. We'll see that. Okay. Then, however, in circular motion, it's okay. Okay. Put your topic circular motion. Put your topic circular motion. If you have any questions, please update me. Okay. Send me also. Thank you. Who is that? Yeah. Just now I see that. Okay. Circular motion means an object is traveling in a circular path. That is a circular motion. Okay. An object is traveling in a circular path. That is the circular motion. Object is traveling in a circular path. Okay. Now, there are two types of circular motions. One type is horizontal circular motion. Second type is vertical circular motion. Okay, second type is vertical circular motion. Do you know the major requirement? Do you know the major requirement that should be fulfilled by an object to move in the circular path? What is the basic requirement? What is the basic requirement that should fulfill by an object to move in the circular path? What is the basic requirement? There should be a centripetal force. That is the major requirement. To have a centripetal force, there should be a centripetal acceleration. There should be a centripetal acceleration. There should be a centripetal acceleration to the direction of here, to the direction of radius. There should be a centripetal acceleration to the direction of radius. It should be in radial. Yeah, it should be in radial. Okay, it should be in radial. Always, this is symbolized by AR. Then AR is, there are three equations. One is V squared over R. I know, I think you all know these things. Huh? This is the tangential velocity, and this is the radius. The omega is the angular velocity. Then there is an equation V equals R omega. Okay, V equals R omega. Then we can apply these things here because AR is now the centripetal acceleration. This centripetal acceleration is applied the centripetal force. This centripetal acceleration is create the centripetal force to the radial, to the radius direction, to the center. Okay. Then AR equals, the main equation is V squared over R. V is tangential velocity. V is tangential velocity. Now we can substitute R omega for this. This is R squared, and this is omega squared, and this is R. Now there is another equation also. AR equals R omega squared. Okay. And there is some other equations, is V omega. It also just use it. Okay. Okay, get these things. Hurry up. Get these things into your paper. Okay. Again, if you are solving a horizontal circular motion, there are three steps, only three steps. First thing, draw the free body diagram. Draw the free body diagram. When you are drawing free body diagram, don't mark any centripetal force. Huh? Don't mark any centripetal force as separately. I mean, don't mark any centripetal force as separately. Separately, not know any centripetal forces are separate. But the tensions, frictional forces, they are resolved to create the centripetal force. Example, see, think this is an object which is traveling in a circular, horizontal circular path. This object is traveling in a horizontal circular path. When we are drawing free body diagram, only weight and tension. Only weight and tension. If this is theta, this is tension. If this is theta, this is theta. Then we are resolving T cos theta and T sin theta. T sin theta is acting as the centripetal force. T cos theta, T sin theta. T sin theta is acting as the centripetal force. No any separate centripetal forces. Only tension, weight. If there is friction, you can mark friction, usual forces. And you create the centripetal force. Okay, you create the centripetal force by resolving or any other things. Okay. Okay, how we will draw the feedback diagram. Then the second part is take the equilibrium. Okay, take the equilibrium to vertical direction. Take the equilibrium to vertical direction. It means this direction. Because this is a horizontal circular motion, only the resultant force is acting to the horizontal direction. In a horizontal circular motion, only the resultant force is acting only to the horizontal direction. Therefore, to the vertical direction, therefore, to the vertical direction, the resultant should be zero. Therefore, you can get vertical equilibrium to these scenarios. Third one is applying F equals ma towards the center. Applying F equals ma towards the center. Center means pure horizontal direction. Pure horizontal direction. If we apply these tricks into this, draw the FPD. FPD is completed. Take the equilibrium to the vertical direction. T cos theta equals mg. T cos theta equals mg. Third step is applying F equals ma. Okay. Third step is applying F equals ma. F equals ma. Then the centripetal force, it is T sin theta. The centripetal force is T sin theta. T sin theta equals m into, if it is traveling in v tangential velocity, then v squared over, if the radius is r, v squared over. If you apply these three steps, definitely you can solve the problem. Definitely you can solve the problem if you apply these things. Okay, get these things. If it is a vertical circular motion, if it is a vertical circular motion, okay, if it is a vertical circular motion, please do these steps, and there is an additional step, that is applying energy conservation. We will do it also. Please write these things. Okay. Okay. Okay then. We have to cover rotational motion and hydrostatics and fluid statics, and we are doing for mechanics. And there are some lessons we have to cover during the month. So we are covering those lessons. We are covering those lessons by both live classes and pre-recorded videos. I will cover them. And as I previously said, during this month, we are conducting a special MCQ discussion, class for your before your exam. Therefore, so hard. If you have any problems, you can solve them with me. Okay, then. I will schedule another day to work like this to do revision. I will schedule another day and update all announcements in our group. So therefore, this is all for today. Because some students are request me, they have some other works after 11 period. Therefore, there's a recording also. I will tell you that because today is the mechanics day. I plan to do light also, but time is not sufficient for that. During this month, we can cover as a speed revision. We can cover all these things as a speed revision, and all announcement will post in the group. And therefore, for today, these things. If you have any questions, you can ask me. Otherwise, you can leave this. If you have any questions, please ask me. For this, and I will make a special MCQ table for you covering all of these things. Okay, during this month. Okay. Okay. If you have any questions, you can ask me. Hello. Why they are sleeping? Because no patience. Even the MCQs will get shy. Yeah, you need to enter 6 group, but it is a paper which covers all syllabus. Sorry, it covers the whole syllabus, but I can send it to you. No worries, I can send it to you. Linear to circular. Can you show how okay, so linear rotation. Sure, I can. Not linear. Okay. Thank you. Okay. It is not linear to circular, linear rotation, no? Linear rotation. Sure, I can. Linear rotation. First of all, when we converting linear to rotational, okay, linear rotational. First we convert the normal motion equations. The first motion equation we study is V equals U plus A. In rotational motion, for the final velocity, we write omega. For the initial velocity, we write omega naught. Alpha. Time is time. The second equation is S equals ut plus half a t squared. Then S equals theta. U is omega naught t plus half alpha t squared. Third equation is V squared U squared plus 2s. Here omega squared equals omega naught squared plus 2 alpha theta. Theta is the angular displacement which corresponding to the linear displacement. The final is S equals V plus U over 2 into D. Here theta equals omega plus omega naught over 2 into D. Next, we know there is a mass in linear motion. In rotational motion, it is moment of inertia. Here this is mass. In rotational motion, it is moment of inertia. Okay, it is moment of inertia. Okay. Then think about force. Force is torque. Torque equals Fr, another equation also. Then we can write that F equals Ma. See, F equals Ma when converts to rotational, it is tau equals Il. F equals Ma when we convert F equals Ma into a linear momentum, mass into velocity. What is rotational momentum? I into omega. Because the mass corresponding to moment of inertia in rotational. Then linear kinetic energy. Linear kinetic energy. This is rotational kinetic energy. Half I omega square. This is rotational kinetic energy. Then work done equals F into S. Work done in the rotational motion, tau into theta. Power is equal to F into V. Power in rotational motion is tau omega. Such a way. Okay. I will explain these things in more deep, yeah, in another level. Okay. I will explain this rotational motion in deeply and doing some complex problems in this special level security expression also. Okay. This is the thing. This is the main thing. Okay. Did you get it? Or any questions you have? You can ask. You can ask if you have any questions. Then you can. Yeah, it's okay now. Okay, all questions I see. So no any other questions? Okay. Don't worry about these things. Don't worry about rotational motion. I will do these rotational motions very clearly before you exam. Don't worry about it. If you have any questions in these things, you can ask me. Are you there? Someone are there? Others have sleep or something? Okay, yeah. Not telling anything, huh? Okay. Okay then. If you have no any questions, we can end the session for today. But don't worry, I will help you in this month for your exam. Okay? Don't you need this too? Okay, welcome. Okay, welcome. No, no for the circular motion. Circular motion is the object will come. Object that are traveling in the circular path. See, this is a circular motion. See, this is a circular motion. But this is a rotational motion. This is a rotational motion. See. No circular path. It is just rotating, just rotating. But this is a circular motion, see. Circular motion. The pen is traveling in a circular motion. But here now pen is traveling in a rotational motion. Rotational motion, circular motion. Can you get the difference between rotational motion and the circular motion? This is rotational motion. Okay, welcome. Okay, don't worry. I will help you. Okay, okay, okay. I will help you in this month for your exams. Don't worry. Okay, I think other people are sleeping or something. Not telling anything. Huh? Even they don't leave also. Because they're sleeping at night. Okay, okay. Okay then. If you have any questions, okay, thank you. Bye. Okay, bye. Okay, okay, thank you. Okay.